Hello students. So today we are going to start with the chapter number 4, that is the structure of the atom. Students, as we all know that everything is ultimately made up of atoms. But the question arises how the idea of atoms emerged. Now very first we will learn the views of Maharishi Kannad. In 6th century BC, Maharishi Kannad, an Indian philosopher, he put forward his ideas regarding the matter. He said that matter is not continuous and it is made up of tiny particles called Parmanus. Students, in Sanskrit the word param means ultimate and anu means particle. Right. After that, the views of Democritus and Leucippus we will study. In 5th century BC, the Greek philosopher Democritus and Leucippus, they also came up with the similar ideas. They thought that on dividing a piece of a substance, one would ultimately get a particle that could not be further divided. And they gave the name atomos. The word atomos in the Greek means indivisible particles. However, students, the theories of Kannad as well as Democritus and Leucippus, it remained forgotten for more than 2000 years. So later in 1803, an English chemist, John Dalton, he put forward his atomic theory known as Dalton's atomic theory. So now we will learn what are the postulates of the John Dalton's atomic theory. Students, the first postulate, it states that elements are made up of very small particles of the matter called atoms. Second, atoms are indivisible, means they cannot be divided. Then it proceeds that the atoms of an element have the same weight. For example, atoms of the element of hydrogen, they will be having same weight. The atoms of different elements have different weights. For example, atom of hydrogen, the weight of the atom of hydrogen element will be different from the weight of an atom of carbon. Next, fifth, atoms take part in the chemical reaction. And the last, the atoms of an element, they combine in a simple numerical ratio with those of the other elements so as to form the compound. Right? However, students, according to the modern latest research of the atoms, it has proved that most of the postulates of the Dalton's atomic theory, they are incorrect, except in that atoms, they take part in the chemical reaction. Now we will learn the subatomic. In the late 19th century, it was proved that atoms are divisible, and it was found that atoms, they are made up of 3 subatomic particles called electrons, protons and neutrons. So very first we will learn about the discovery of electrons. Under ordinary conditions, gases, they are bad conductors of electricity. But students, gases, they become a good conductor of electricity if the pressure of the gas is very low and the voltage applied is very high. And these conditions, they are achieved in a discharge tube. So what is a discharge tube, students? A discharge tube is a long glass tube at the two ends of which are sealed 2 metal plates. And these metal plates can be connected to high voltage source that are called as electrodes. The electrode which is connected to the negative terminal is called cathode, and the one which is connected to the positive terminal is known as anode. Right. Then there is also one side tube. This you can see, boys. There is also one side tube which can be connected to an exhaust pump, and that is used for lowering the pressure of the gas inside the discharge tube. Now students, when a high potential difference means when a high voltage is applied across a gas in a discharge tube, taken in a discharge tube under a very low pressure, you can say about 0.001 millimeter of mercury, some radiations, invisible rays, they are emitted from the cathode. Invisible rays, they are emitted from the cathode, and these radiations, they move towards the anodes, which glows, and the rays so produced from the cathode are known as cathode rays. Students, now we will learn the characteristics of the cathode rays. Students, Sir J.J. Thomson and others, they found that cathode rays, they have the following characteristic. So what is the first characteristic of cathode ray? The first is that cathode rays, they travel in a straight line. Means they originate at the cathode and they travel in straight lines. How it has been proved? It has been proved like this. When an object it is placed in the path of cathode rays, a shadow of the object, it falls on the wall just opposite the cathode. Now students, a shadow can be formed only when the rays they travel in straight lines. So in this way, it has been proved that cathode rays, they travel in a straight line. Now we will learn the second characteristic. The second characteristic, it states that cathode rays are stream of particles. Now how it has been proved? It has been proved like a light paddle wheel was placed in the path of cathode rays and it rotates. Now this shows that some particles strike the plates of the wheel. Now we will learn the third characteristic. What is the third characteristic? The particles constituting cathode rays are negatively charged. How it has been proved? It has been proved by the fact that cathode rays bend towards a positive plate in an electric field. After that, students, we will learn the fourth characteristic. So the fourth characteristic of cathode rays states that the particles constituting cathode rays are alike. Means they do not change with the gas, the electrodes and the kind of the glass which is used for making the tube. So students, Sir J.J. Thomson concluded that the particles constituting cathode rays are a universal constituent of all the atoms, and these particles were named as electrons in year of 1897. Students, now we will study about the proton, the second subatomic particle. Students, as we know, an atom is electrically neutral, but the electrons present in it are negatively charged particles. So the atom must also contain some positively charged particles so that the overall charge on it becomes zero. So these particles should be found in the discharge tube itself when cathode rays are formed. Now let us study about the anode rays. Students, Goldstein, he repeated the cathode ray experiment by using perforated cathode. Now what is the word perforated means? The word perforated means holes. So students, he observed that there was a red glow. He observed that there was a red glow on the wall opposite to the anode. So some rays must have travelled in the direction opposite to that of cathode rays, that is from anode towards the cathode, and these rays were known as anode rays or the canal rays. Now students, why they are termed as canal rays? Because they move through the perforations or the canal. Okay? In the cathode. So it was found that these rays, they contained positively charged particles, so they were termed as a positive rays. Now students, what are the characteristics of the anode rays? So students, now we will learn the characteristics of the anode rays. The first one is anode rays travel in a straight line. Second, they are made up of positively charged particles. Third, positive rays are deflected by electric field and magnetic field but in direction opposite to the cathode rays. So this means that these rays consist of positively charged particles called protons. And the last, the particles constituting anode rays, they differ with the gas used in the discharge tube. So now we will study about the discovery of neutrons. Students, by now we have learned that only one particle that can account for the mass of an atom, right? And that is the proton. The electron has negligible mass. Negligible means no mass, right? But except in case of hydrogen, it was found that the mass of an atom is greater than that of the protons in it. So further, the unaccounted mass is either equal to or a multiple of mass of a proton. So this suggested that an atom must contain one or more kind of a particle which should have the same mass as a proton but no electrical charge on it. So these particles were named as the neutrons as they should be electrically neutral. So students, experimentally the neutron was observed much later in nuclear reaction, and it was in year of 1932 James Chadwick. The James Chadwick he bombarded the element beryllium with alpha particles, right? And he observed that beryllium, it changes to carbon and neutron. They were emitted in the reaction. Students, you are going to learn this nuclear reaction in your higher class. Today's homework is that we have gone through the topics, that is Dalton's atomic theory, subatomic particles, electrons, protons and neutrons. So your homework is that you have to read these topics given in your book, and if there is any doubt you can ask me. Thank you and take care.